Hello, I'm Jake. I think a few of the people in the crowd recognize me from here, there, or absolutely nowhere. A little bit about me. I'm a cybersecurity student, third year, and I'm representing Warwick AI Society in the Python Cross Society Python course. We're on week 4, which was supposed to be handled and presented by our lovely Laura, but unfortunately she can't make it, so you've got me instead. Sorry in advance. But today we're going over file handling and command line. Most of this will be going into file handling, but command line sort of comes hand in hand with that anyway. So you've probably already done these. So you've done variables, data types, exceptions, flow control, functions, lists, loops. These are all very core programming fundamentals, as you are more than well aware of now, I'm sure. And today we're on number 4. So file handling, the command line, and libraries that we're going to go over. So what we're going to do is, I'm not really sure on the technical abilities of you lot, so I'm going to assume not zero knowledge, but pretty close to. So I'd just like to go over files and folders, because this is something that messes up everyone from great programmers all the way through to beginners. And if just going a quick bit over what a file is, what a folder is, and how they're all structured on your computer, if that saves you 1 or 2 errors, then it's absolutely worth it. So I'm not going to bore you with the details, but a file is a big blob of data on your computer. You're probably well aware of them. You use them for your notes probably, everything, text, EXEs. Your operating system itself is just a bunch of files. Everything's just a bunch of files. So they're just a big blob of data, and each one has a location on your computer. Those are in your folders. So you've got files and you've got folders. Folders are where they're stored, and files is the data. This can get very, very messy very, very quickly. I'm sure you've had instances where you've downloaded a file and spent half an hour trying to find it again because Word saved it in the weirdest location you've seen in human history. But it will have a reference, and that is described by the file path. So the file path is the string that will tells you which folders you have to go through to get to your file. And the key thing why I'm telling you this, there's an example, C uses Jake's computer documents. I will say those double backslashes that you see, that's Windows only. And a lot of the time it's forward slashes, or sometimes 1 backslash, or sometimes 2 backslashes. It's going to be one of those 3. Good luck, figure it out. Normally a forward slash, but Windows is a bit weird. But the key thing is there is a difference between absolute file paths, which is the one there, and relative file paths. And this is the thing that can really screw over some developers. Because if you get a relative file path wrong, then you think, why is it not working? And it's because it's not finding the right file, or it's pointing somewhere else, or it's just not finding anything at all. And that's because of this relative file path stuff. Relative file path stuff is quite simple. Instead of being C uses Jake computer, if we are, this doesn't, there we go. So if we're at C users and we want to get through to this documents here, we just have to be, the relative file path would be Jake's computer documents. Quite simple. I know this is probably stuff that you are well familiar with, because by the looks of it, everyone's owning a computer at the moment, and that'd be a concern if you weren't, at a Python course at least. Yeah, so now we can get onto the content. Also, one thing I will say is, if you have any questions, if I'm going too fast, too slow, anything like that, please just shout it out. Heckle, I'm here for it. So file reading. So when you've got a file, like a TXT file or CSV, you'll be doing a lot of them. You might recognize .exe being an executable, anything like this. When you've got any sort of file on your computer and you are dealing with a program, you will have to probably read it at some point, or read files. And how we do that in Python is quite simply with the open command. So as you can see there, f equals open demofile.txt, comma, r. And as you can see there, we are using the relative file path, because absolute file paths can get a mess. So I recommend trying to use relative where possible, but that's where things can start screwing up if you've got a file folder that you don't know about in the middle. But there we go. So to break that down a bit, what we're doing is we are opening this txt file, text file, called demo file, and we're reading from it. That's the R. And then we're assigning the handling of that file to F, which is a very common thing in Python. You can call it f. I don't know if you can call it file. Is that a reserved keyword? Is file a reserved keyword? No, you can call it file if you want. But we're just going to call it f for simplicity. So this opens the file. Each file can only be opened once at a time. And this is a very important thing because a lot of the time, I've had it loads, you will try and open a file and you'll be getting weird errors. You don't know where it's coming from. And it's because, oh wait, I'm running the program twice. One opened the file, the other one then can't. It's called file locking. So, as it says, this then assigns the open file to f. And then from there, we can read the contents of the file with the below. So we can do data equals f.read, and then we can just print the data. And what that will do is it will automatically open up demofile.txt, read it all in, and then print it all out. Pretty much like opening Notepad. That's what Notepad does on a very, very basic basis. So when we're reading a file, it's not quite as straightforward as that. It is a lot of the time, but I imagine if some of you are here perhaps to be going into the sort of big data side, so you're dealing not just with a couple lines of text, you're dealing with gigabytes, terabytes even of data, you can't open the entire thing at once. That is unfeasible. It's like reading an entire dictionary when you only want a couple words. So what we can do is we can start traversing through the file without having to have everything, as it's called, in memory. And that's with this f.seek. So when you've got a text document open, you know the little flashing cursor? You have the same when you're in programming as well. You have something that's called a bookmark or a cursor. I prefer cursor, but I think it's called a bookmark in Python. And we can use f.seek in order to move that cursor a set amount. So instead of before, where we just read the entire file and printed it out to the screen, we can just read a certain part of it, or we can move around the file without having to deal with the entire file. And that's this f.seek. So there will be more in the Python course, the Jupyter Notebook, that will go into what f.seek does. But as a very quick basis, you've got f.seek, you've got a 0 and 0, so that puts you to the start. If you change that first 0 to an 8, you'd be 8 into the file, for example. If you change the second number, it can be a 0, 1, or a 2. I won't get into the detail here and now, but it does explain this all in the Jupyter Notebook. But it basically says, whether you're starting from the start of the file, the end of the file, or somewhere in the middle. So getting on to the file reading now. So currently, the Python script, which is just the open, the read, and the print, currently we've still got the file open. And that's not very good if this is a sustained program, for example. So it's a program that's going to be kept going for a long period of time. You don't want to keep this file open. It takes up memory, it holds up the file, no one else can touch it. It's your program's file. So we need to close it. So we need to say, hey, I've read the data, I've done what I need to do with the file, I'm done with it. And how we do that is with closing it. So we use f.close. This just simply tells the computer, hey, done with the file, don't need it anymore. And it's very good practice to put it at the end of any program you're working with that works with files. So now anyone can access the file again, because your program is no longer handling, as it's called, the file. Now, we've read the file, but that's not too useful. Well, it is very useful, actually, sorry. But we need to be able to write to the file, modify the file, anything like that. So if you remember, we had that little R in the open for read. We also have a W or an A for write. There is a difference. W is we're going to basically throw away the entire file and dump new data in. A is we keep the entire file and we append A to the end. So we've got append or write. So now we're also going to have a look at the with as well. So what this does is it will overwrite the file starting at one line. That's the demo file.write bit. However, you might notice this with as demo file. With is a pretty Python-y concept, I'm not going to lie. I've not seen it in other situations or scenarios, but it basically means with context. So the context is open demo file txt w for write. That's the context. You're going to throw the context into demo file, but then once you end that with, so once you fall out of the with, that's gone. You no longer have to deal with it, you no longer have to close it. So we can also use the A as well. So instead of rewriting the entire file with I like trains, we're instead going to add I like trains to the bottom. Yeah. So as a TLDR, what we've got is if we're going to use W to open it, we're going to start at the beginning, throw away all of the contents, and we're going to write whatever new stuff we need there, whether it be the same, different, whatever. However, if we were to use the A instead of the W, then we're going to add to the bottom of it. So we're going to keep that and just sort of keep on writing to the bottom of it. There. So now we go into libraries. A big part of programming, and one of the things you'll hear programmers say all the time, is just don't reinvent the wheel. It's a very common phrase outside of programming as well, but just don't reinvent the wheel. How do we not reinvent the wheel? Well, we steal the wheels that someone else has done and throw it on our project. And that's exactly what libraries do. Libraries are collections of code relating to certain functions. So there are very basic examples from the functions you've seen. So open, that would be from a very primitive Python library, but we'll also go into other libraries, for example, random, which gets us random numbers. So instead of us having to figure out all the maths of how do you get a random number, getting the date, time, I don't know, hashing it and then getting the last couple values, you can instead just import a random library that does it really well, and it's very easy and someone's already done it. So it saves you a lot of pain, and you'll get a lot of this sort of stuff in programming as a whole. So they're very useful because they allow us to leverage code other people have written. Literally just copy their work, steal it, put it out. I know university teaches you not to plagiarize. In the programming world, absolutely do. I highly recommend it. It will take you far. Beware what you're plagiarizing though. Some people put stuff in it. Some Python libraries are included when you install Pythons. These are the standard libraries. I believe every language has some standard libraries. But Python will also allow you to add more. If you've ever used pip install, that's how you install other people's code. That's how you install other people's licenses. Other people's libraries. But anyway, the standard library, we've got random and we've got sys. Sys is system. That's how you do system-based things. I can't remember any off the top of my head. I think some of them are like for environment variables and things, but whatever. So the one we're going to focus on is the standard library, so that we don't need to reinstall them. And how are we going to use it? We use the import keyword. So we're going to import someone else's code, and this allows us to use their functions, their classes, their procedures. Everything they've written, we can just yoink it, use it, done. Saves us a load of time. And there's an example. There's a very basic example. It gets a random integer, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, between 0 and 10. I don't know if that's bound inclusive, but like, whatever. That's if you want to import just a certain part of a library. So some libraries are very, very big. You can import just a very small part of it so that you're not clogging up your computer with more stuff than you need. So you can use from random import randint. So instead of doing, as we saw before, random.randint, we can instead just import the randint and just use randint, like that. Does the exact same thing, bit shorter, bit nicer, bit cleaner. It's preferized where possible. A lot of the time, though, you just import everything. Anyway, pandas. I have a feeling this is one of the surprises Laura kept from me. I'm not watching it go. There you go. A lot of pandas. So when you are looking at big data, databases, these huge, they're called data lakes, huge quantities of data, or even less, you will need it in some sort of structured format. There are many structured formats. Some of you might have heard of SQL or SQL. There's other ones, JSON, XML, whatever. The one we're going to focus on, though, is CSV, which stands for comma separated values. And it's a very, very basic concept. It is literally just, the top line is normally headings. So it might be ID, comma, name, comma, age. And then every other line will be someone's ID, so 0, 1, 2, whatever, comma, their name, so it might be Jake, Joe, I can't think of any other names off the top of my head. And then the last column, it'll be then comma, and then their age. So that's how a CSV works. When you start working with big data, a lot of data is formatted in CSVs, so this is quite a useful skill to have. So reading data using open can be quite cumbersome when working with CSV files. That's because of these commas. If you've got strings in CSVs, so let's say you've got, I've written my entire dissertation and I want to put that in a single value in a CSV, there's going to be a lot of commas in that. And figuring out what's a comma, what separates the values, quite difficult. So what we can do instead is just use someone else's code, use a library. And the one that we're going to focus on is pandas. Pandas is an incredibly powerful data science tool. It allows for, well, reading, I think it allows for writing, definitely allows for data visualization of these sorts of things as well. But what we will look for is the importing and the processing of our CSVs. So, Panda uses something called a data frame. It's basically, I don't know how to describe it really. I think of it as just like a gloop of everything Pandas has about that data. You import it and Pandas goes, okay, here's all the information I can find, here's all the functions that you can use on this sort of data. I don't know if that's completely correct, but it's close enough. So data frames are a way of storing, oh, there we go, various columns of data with a shared index regardless of their data type. Allows data sets containing strings, floats, ints, etc. to be stored within one data frame. So in the example of ID, name, and age, name would be a string, because Jake is not a number, but my age is absolutely a number. So we will focus that on more in week 6. I know Laura's very keen to go over this. I think she's a very big Pandas fan. When I asked her if we're doing Pandas, she just sent me a spam of the word Pandas over Discord. It's kind of annoying. Either way. So in week 6, it'll be going into data visualization using Pandas. But for now, what we'll look at is the CSV. So command lines. How many people have seen a really cringe hacker movie where they've got all the green text falling down the screen and people are bashing things on keyboards? And as a cybersecurity student, it makes my soul hurt. It really does. But those exist. It exists. It's very useful, and very old computers use them a lot. And it is the fundamentals of every computer, pretty much. So what is a command line? I've got a very old command line over there. Command lines are the text-based interface with your computer. So how you're looking at now is with a GUI, with a graphical user interface. You can click on stuff, you can move stuff. However, life was not always that simple. We had to physically type it out, and the format of a command line thing is you use the command, which is normally like an executable file, and then you give it some arguments. And that's like the context in which it runs. So if we have a closer look at command line arguments, command lines arguments are used to run, command lines are used to run programs. Programs that need context for their runtime, sometimes, not always, but sometimes. So this might be, good example is the cd command, as you would have seen there. Cd is just to change directory, to move about when you're in this command line interface. You need cd, which is the thing, but then you need to select where are we moving? So you give it documents. So we can use command line arguments for this, and they come in 3 types. We've got flags, so we've got which is like -v, -c. They're a bit complicated, but we can add them in Python. I don't think we're going over that today. The one that we will be focusing on is the file directories, and I think maybe a bit on the parameters as well. I don't think, yeah, no, we haven't got an example, but I can't actually give an example because I don't know the Windows command line. I do apologize. Either way, when you're in the command line, there will be a load on it in the Jupyter Notebook, and I'm happy to go through that if the Jupyter Notebook doesn't explain things for anyone well enough. But command lines are there, and they take in flags and stuff. I think that's everything.